All right, here we go. Number 17, working our way through it. This one here, there might be an easier way to do this. Oh, no, okay. I was thinking about multiplying both sides by the conjugate of the denominator. That's a good strategy. But we can also do it a slightly different way, which might be nice here. The r for both of them is going to be square root of 3 squared plus 1 squared, which pops out to be 4, 3 plus 1. And so both of them have an r of 2, the numerator and the denominator, I should say. And the theta for the top, I'll call that theta t. The theta for the top is going to be the arctangent of the y value divided by the x value. And it's in quadrant 1. And so arctan just tells you exactly what you need. I guess we're in a no calculator problem. So we need to think about where the y value is less than the x value, and that happens at pi over 6. Theta for the bottom, theta b, is going to be the arctan of negative 1 over root 3, and that's in quadrant 4. And so we would have negative pi over 6, or we could just write, I guess, 11 pi over 6. It's the same thing. And so then the top of the fraction, the numerator, becomes 2e to the I pi over 6, and the bottom becomes 2e to the I negative pi over 6. And so we end up with 2 cancels with 2, e to the I 2 pi over 6, or e to the I pi over 3. That's one way to do it. Just, I guess, because I got the time, I can just show you what the conjugate would look like, where you go root 3 plus I, root 3 plus I, and when you multiply that out on the bottom of the fraction, you get 3 minus I squared. And on the top, you get 3 plus 2 root 3I plus I squared. And so what that ends up being is I squared becomes negative 1. And so you have 2 plus 2 root 3I over 4, or 1/2 plus root 3 over 2I, which is the same as what we just found using the polar form. So it's super nice when it works out both ways. And the theta is in the right angle and everything is good. Okay, now show that for n in z plus, that thing is true. I guess, is this an induction proof? Maybe this is an induction proof. Um, yeah. Is there an easier way? Let's try to write it out. Okay, let me think here for a second. So the first one, this we already know is expressed. That was our numerator. So we already know that one is 2e to the I pi over 6. And so if we raise that to the n, that won't be too hard. And the second piece we already know is 2e to the I negative pi over 6. And if we raise that to the n, let's see if we can do it with a direct proof. That's nice. If this doesn't work, I'll switch to doing induction. So this becomes 2e to the I n pi over 6 plus 2e to the I negative n pi over 6. I can write this in terms of cosine and sine, and I can actually factor out the 2 as well. So I have 2 times cosine of n pi over 6 plus I sine of n pi over 6. Then continuing on with the negative, plus cosine of, oh, this will work out, negative n pi over 6 plus I sine of negative n pi over 6. And the nice thing is, in an earlier video, I used the fact that that we should all kind of have this down by now, but that cosine of negative x is equal to cosine of x, sine of negative x is equal to negative sine of x. And so what ends up happening is this sign cancels with this sign, but the two cosines are identical, and that's why we get the 2 to the n plus 1. So we have 2 times 2 cosine of n pi over 6, and that becomes 2 to the n plus 1 cosine of n pi over 6, which is as requested. And so now it was a show that, so we can delete everything, and now we're just plugging in 8 as our n value, and that should be pretty straightforward. So the value of this is just going to be 2 to the 8 plus 1 cosine of 8 pi over 6. So that's 2 to the ninth. I'm not even going to bother to expand 2 to the ninth out. 2 to the ninth is a great value. 8 pi over 6 is the same as 4 pi over 3, which is pi over 3 past 180. So I think that's a cosine of negative 1/2. So I have 2 to the ninth times negative 1/2. So that's going to be negative 2 to the 8th. Okay, kind of a nice problem. That's it for problem 7. Let me know if you got more questions. Or 17, not problem 7.